Hi. Hi, hello. I forgot to put my name on the slide, but my name is Nikola Jokič. I'm a CTO of Digital Assets Powerplay. We are based in Croatia. But we are really present in the Slovenian scene, at least in cooperation-wise. We are focused on algorithmic trading, but today we're not going to talk about that. We're going to talk a little bit about running Swarm on RedHat OpenShift. Has anybody heard about OpenShift? Perfect, nobody. Almost nobody. Has anybody heard about Docker? Dockers? Yes. So you have Dockers at the bottom layer. Then if you have multiple Dockers and you want to orchestrate them, then you have Kubernetes. If you want to deploy Kubernetes in a more serious environment, then you will probably use OpenShift, which is basically, let's say, a wrapper around Kubernetes stuff. So the talk today is how to run basically any blockchain software in sort of an enterprise-ready, production, deployable environment. Well, if your code is production-ready, then this thing should work. So how do you do production-ready deployments of Web3 software? Ethereum, Swarm, Whisper, I think these are the most three important softwares, piece of software that you can find today. I'm not sure is the software production-ready, but I think Red Hat OpenShift is. So Red Hat OpenShift is an open source company. They started in 1993 with a fork of Linux. They are fully open source and they are worth in some billions, I think, their market cap. They have around 11,000 employees and they are focused on like an open source but enterprise-ready solutions. You will mostly find them in banks or some bigger institution which have a bit more serious deployments procedures. We deploy our platform on the OpenShift platform. Some parts are bare metal. So what's the idea? Idea is when you develop some piece of software, that's one part of the problem. Your software now works nicely, it passes tests, but you must somehow put it in production. What you can do is maybe SSH into a machine, then do a git pull, build somehow, then run it, but it's not the way that you should do it. Maybe you have some more rich Jenkins procedure that will deploy this thing, but then there is the question how the production is on one state, I do some development, then I somehow need to switch, move the old production out and then put my new dev branch or something in production. These kind of questions are, well, anybody's problem that deploys some software into the production. OpenShift really helps here. Since we started to use it, we kind of sped up maybe 5 times in terms of our efficiency. So what would be nice to have from your own deployment software? It would be nice to easy to scale, so you can maybe click a plus button and get 10 more Ethereum nodes that you need maybe because the attack on your backend is a bit higher. It would be nice to easily test different topologies, maybe to have an environment in which you can deploy some kind of network topology in your private network, then maybe test out what happens when the network splits, or maybe what happens when some hard work happens. If you're doing it maybe manual, it's kind of tedious process. We were previously on DigitalOcean or AWS, and it was like you go into this 10 machines, then you set up this kind of situation, and then you see what happens, but it's really hard to reproduce because you're not just copying the source code or the build of your project, but you need to replicate the environment. Ideally, your deployment process would be infrastructure independent, so it means that any kind of hardware you have, you can deploy on it. We have on-premise hardware and built from the hardware layer, so we installed OpenShift on our hardware, and it's a non-trivial installation, but basically it's a way to go, I think. So what's the part of the technology stack? It's Red Hat Enterprise Linux. If you are for a more open source solution, you should go with CentOS. which is basically an open source fork of Red Hat Enterprise Linux, Docker, Kubernetes, and OpenShift. So you have some text here that you can read what's this thing all about. So what we did, we kind of were surprised that you cannot. On OpenShift, we have ready templates to deploy almost any kind of software. If you need the Postgres database, you can like yes, and you get your own persistent Postgres database. If you want some kind of a Kafka cluster, if anybody uses Apache Kafka, there is a Streamzy project. Red Hat recently just started to work with them. It's basically yes, and you get tens of Kafka nodes connected and working together. So it's a really, really easy way to get more complex deployments of your software up and running and template it so you can reuse it in some other projects or other environments. So what we did as an experiment, first we started with, let's have one parity node. We use parity client for development. So let's have it just deployed. This template is open source, so you can see it. And then we kind of started to experiment with bit more advanced OpenShift possibilities. What we did is we deployed one validator node in a proof of authority Cohen setup, 3 load balanced secondary nodes, which are not mining, and one block explorer that basically requests get load balanced across these secondary nodes, and this validator node is actually mining the blocks or assigning them, whatever you like to say. What's now nice about this, we'll go check out how does description of this deployment looks like, but basically you kind of describe, I have some service, that service has a root outside. Behind this service you will have 3 pods. Each pod has limitations of X megabytes of RAM or this much of processing power. This validator node has a bit more. It has also persistent storage, so you reserve some space on the hard drive, and then you can easily redeploy it. What we can do is basically, give me a sec. What we can do is maybe look how does it. Let's see how does it look in OpenShift when you try to deploy it. So let's have a hands-on. This is OpenShift user interface. It's an OpenShift online solution, so we can open up an account like an Amazon Web Service or something like that and pay some money for the resources. But basically, we can install it locally. I recommend Minishift. It's like a small OpenShift that you can run locally. And here you can do a bunch of things. Ideally, you can start any of these things. Behind each of these things is a Docker image with some description around it that describes how to run this Docker image. This is all Red Hat supported. What you pay with Red Hat is basically support. There you can have somebody on the line. Please help, something is crashing in my system. And that's what you pay for. The code is basically open source. So you can deploy a bunch of stuff, but you can also import your own templates. This is the one that we developed and open source. It's a Parity Consortium starter that we have called it. You can go next. It's a bit description what's this all about. And basically now you have some configuration phase in which you can give a name for this consortium. You can give it network ID. You can set block reward. You can define set step duration. If anybody looked into Genesis JSON of the Cohen network, these are basically the parameters for the Genesis block. So we can here define who's even the validator, what's the validator identity, how many gigabytes of memory should the validator have for a persistence, what's the RAM limitations for the pod, because you can also set some limits if your project goes crazy or you have some kind of memory leak, so it doesn't eat up the resources of the whole project, but stays contained in his own limitations. So it's kind of nice. You can even set your private key so it immediately starts to mine blocks. When you click create, basically you wait a bit, and then what happens is we can go to the deployment. Let's go to this view. So what happened? We have a template. We have a template. Basically, we have a block explorer, which is forked, I think, Etherlite or something like that. The one that can show, there are links, so I can send you which block explorer is that, but it's an open source solution. We just packed it to a Docker, non-root Docker image based on Red Hat Enterprise Linux. What's also deploying here is the secondary nodes, those load balanced one from the power play parity 195 CentOS image. We did our own because almost anybody today that writes Docker images does so in a root way. So at the end, the user that starts the container is root user. And although you're in a container, this is not the right way to do it. Even platforms like OpenShift will complain. So when you write your own Docker files, please take care that at the end, you kind of switch to a non-root user and then fix some access for your user so the project can work. We are kind of talking with Parity to fix their own CentOS image, but for now this one is enough. What we deployed is 3 pods, so it's 3 copies of the same Parity secondary node, and here is the validator node, the only one which actually signs the blocks. What we can also see is basically services. So you have different services that say, you know, I have some service that I want to expose to the outside world, or maybe between those pods. I say this service exposes on port 3000 some kind of selector, and then inside I defined on which pods the service will load balance and what are the rules of load balancing. You can define some weights, so you spend like 90% of traffic to one pod. You can do even crazy things like have 10 different REST APIs, all load balanced, although they are not the same project and not exposing. You will not get good results, but you can actually do kind of crazy things. There are also routes. So when you define a service, you can define the route and say, okay, create me a route that will go to some target port that service exposes. We can maybe try to go and see, is the block explorer up and running? Internet is a bit slow, so we'll give it some time. Until this loads, we can go check a bit about, let's say, config maps. Config maps are basically your configurations for the Dockers that you deploy. So we can maybe look at the genesis that was defined. So some step duration was defined during the template creation. Some block reward was defined during the template creation. Whatever you decide to expose, basically, you can set up in the initial setup. If I edit this file, change some parameters and go to pod and click redeploy, it will basically redeploy the thing. You can pick between two types of redeployments, like recreate, so it crashes the new one, it crashes the old one and then brings the new one up, or you can do like a rolling deployment in which you kind of keep the current one alive and then destroy the other one. Okay, so we have the block explorer live and running. Basically, no blocks are still mined. I think that the nodes are still looking for each other, although what we did is we kind of told them that there are some reserved peers. So there is one peer that will connect all other nodes together. So what's the idea here? You can see that you have like a really nice control over the process of deployment. You can, if you like, you can basically do something like this, like go to a secondary node, click plus, and it basically scales to 4. You can define some rules. If the CPU usage goes up 10%, then scale to 5 things and stuff like that. So this is currently the only way to easily start some Ethereum software on OpenShift. We hope that the Red Hat guys will wake up and kind of prepare more software. So this is about it. I scratched surface a bit with the, let's see, did it start to mine? Still nothing. Okay, let's not wait. Let's go back. So how does the template look? Let's maybe just check this thing out. So let's first look at the basis. Basically, this is the Docker file. that deploys the parity node. What we basically is, we get their own build of RPM. We should basically build this RPM inside the Docker image, but this is also okay. And then at the end, what we do is expose some ports and say user 1001. So it's not the user one, and entry point is basically parity. Any other parameters that you want to move forward to this Docker image will be basically applied to this entry point, although you can even change the entry point and stuff like that. So this is a non-root Docker image of parity. If you like to use it, you can use this one because there are no other non-root images out there. Yes, I can say I'm coming right now to the swarm part. Thank you for the push. Let's move. Why swarm on OpenShift? Okay, at the end of the day, it's all about the data. We need to store a bunch of data. What we do is we collect the data for our algorithms. We collect thousands of market pairs, and it's a shitload of data that we need to store somewhere. Why do we want swarm? Because we think there is a problem. Who trades cryptocurrencies here? Almost half. Okay, and do you have some kind of algorithms written up? Or you're like manually clicking? Manually clicking? Okay, when you're in the algo trading environment, you basically see that a bunch of guys are writing their own algorithms and collecting their own data. And that's basically a problem, because I collect I collect market data, you collect market data, and this guy collects market data, and it's basically the same data. And we have a problem because then the market is not efficient, the data is not free, and it's free on the exchange level, which is really disruptive. So we somehow must finish to this endgame, open market data. You must all collect it together because it is public. And today, if you want to backtest some strategy on Bitcoin from 2009, you have two choices. You can either buy the data, which will cost you thousands of euros and you cannot verify it, or you can maybe ask your friend, or you can maybe like send an email to an exchange, but basically you are fucked. Although this data was free, and each minute that the day goes, we have less and less trades collected, and we have a bigger problem to the future. I believe Swarm is the answer for the storage layer of this problem. We need to somehow publicly store this data, and what else do we need? We need to somehow publicly deduplicate it, because if 5 of us sees the same trade, ideally we would write only one trade to the Swarm layer. Now an example of running Swarm on OpenShift. Not gonna happen. There is no Swarm on OpenShift currently. Or this is Croatian rapper, he says ne može. No go. It won't happen. Why? Why? It's difficult to find source code. Who can tell me where the source code of Swarm is? You, the guys, you're the maintainers, yeah. It's probably on some kind of branch on Geth, I think, is it? I think so, yes. It's difficult to detect which branches should I pull to get a stable build. It is difficult to filter issues because I really don't know what the fuck you guys think an issue is. Even if I think an issue is, I really don't know where to put it. It's kind of fucked up. It's difficult to detect which PR to pull to get some features. I heard some guys like, you guys are doing a great job, you know, it's a fucking serious big piece of software that you're developing. And you're fucking developing with another piece of software that doesn't have any relationship to this. It's like Ethereum, Swarm, two fucking pillars, two fucking totally different scopes in the same fucking Git repository. Come on, don't fuck me. And at the end, it's difficult to collaborate. Yes. You know why? Because I cannot find a place where to talk with you guys. You have Gitter channels, you have everything, but you don't have the core, you don't have the Git fucking repository. Do you have? Am I wrong? Okay. Is there a repo coming, like an organization, Swarm/Swarm? I cannot really find a GitHub repo containing Swarm code. I can find Ethereum, Go Ethereum repo finding Ethereum source code, and then you have some convoluted way finding the source code of Swarm in it. And then when you build it, I must pull the whole Ethereum's repository, and then I get 5 binaries out, and then I need to clear everything out and get just the Swarm binary if I want to run it standalone. Isn't that true? It's kind of not right way to do it, you know? If this was just a feature of Ethereum, I would say, yes, of course, you know, develop it. But this is like a even more important pillar than fucking Ethereum.
Okay, so where did you guys help us with this?
What?
If you know, for example, how to make it better, how to make these endpoints better, please help us.
Yes, this is what I'm sharing. I'm sharing, get a fucking separate GitHub repo, because this is the only one thing that you need to do to speed this project up. Because then, as a CTO, I can pinpoint to my director, look, this is Swarm, this is the source code, we can verify it. Then he goes, okay, nice, we can send this to these guys to check what Swarm is all about. Because we can read the source code. It's really hard to fucking read the source code. I always like to read the source code when I see a repo.
Why is it difficult to read the source code?
Because, let's go. Let's go. GitHub, give me a sec. And then what's it? What's the Geth? No? Ethersphere. Oh, so it's not like this?
That's the first problem, right? It's, there's another repo, yeah, right? It's not the same.
Yeah, so, you know, these kind of issues, and I think that I really don't have any other objections to this project. I just think that we need some exact point where everything is happening. But I did contributed my energy to think about this for the last 6 months. Yeah, it's difficult to think, you know. So, I think Swarm must separate from Geth. I think Swarm must define build and deployment processes that are exact for Swarm. I think Swarm must manage his issues independently because it is an independent project. And I think Swarm must provide a non-root Docker image ready to be run because developers of today are all about containers. Like 5 years ago, they were like virtualization, and now it's fucking containers. Give me a Docker run and it's up in 5 seconds. I didn't test as hard into a machine for I don't know how much because you get a Docker image that just runs. What I do is just apply configuration to it.
I think that the Go team did like a few weeks ago, they moved the Docker images to non-root users.
Yes.
And they broke compatibility with half of the users. Everybody assumed that it was staying root.
Yeah.
And of course this is broken, but you know they have to go back for that reason, so it's not.
No, I'm not saying this is easy. This is fucking hard problem. What I'm saying is that each day that we continue convoluted with some other code base, it's going to get more difficult. And my attitude in development, something doesn't work, I take an axe and I just chop it down and it goes down and then you rebuild it again. Because you don't, it's kind of wasteful of energy. So my message is, at the end of the day, please, you did a perfect, nice job with Swarm, and I think that you need to refocus from implementing features for Swarm to helping the community help you. Because there are a bunch of us. What I can offer is time, I can offer developers, and then I can offer storage, because we have terabytes of storage free for Swarm, and I can offer some money, but I think the money is the least of our problems for this project. So please allow us to gather around the code base, and please stop hiding, because there is a sentiment, let me just wrap this up. I talked with people on this conference, and when I talked with people, I said, okay, do you have some issues with the Git repo? And like everybody's like, well, yeah, there is a really convoluted way. And I asked, but why is it like so? And like few people told me, you're doing it on purpose. You're flying under the radar. And I'm not sure, first of all, is this true? Because I'm not sure what would be your motivation to fly under the radar. And I just think that we are over-focused on Swarm as a product and like what the features are and not what's the ecosystem that it will grow.
Let me answer this because question to us. So, unfortunately, I have to disappoint you, but the truth is probably less mystical and more close to reality. That we just probably suck at certain things. We suck, or let's put it in a kind of milder and kind of more up to the point, like objective way. we don't have bandwidth for proper community campaign, like evangelism. We don't have bandwidth for holding together all this like DevOps stuff, apparently. So any contributions in that regard, even if it's like bullet points of what you find as pain points as developers to connect with us, would be very helpful. And once we have that kind of spelled out, we can start targeting these problems. Or maybe you can contribute even developer efforts, like in that regard.
This was exactly my onboarding experience as well. I spent several days going down one path only to then learn or discover a wiki page over here that pointed to another one. There's several wiki pages that are outdated and that just need to, like, at the top say, hey, this wiki page is outdated, here's a link to the latest version. So you've done one of the things that I considered doing for part of my talk was kind of collecting together. I mean, this is like a project manager role that you've taken the initiative on and done. I'd be happy to take your slides and put them as issues and to help manage the actual like pulling it together because yeah, these were real challenges. I think we're getting to the point that we're hurting ourselves because new members of the community can't onboard and contribute in meaningful ways. And so I'd be happy. I think at this point, I do know where we can take this and we can put it and we can organize a little bit more. And I definitely agree that Victor's time and other core contributors is better spent continuing to do what they're doing, and we do need probably part of the community to step up and take on more of the community management, the organization, the maintenance, those smaller tasks that every engineer hates to do. And so it's also a really good way to orient yourself around the project is by taking care of these maintenance tasks. So I'm happy to volunteer and help you get this implemented.
Yeah, just one other thing I was going to add, though, is that sometimes the decision makers, the people writing the code itself, are most aware of breaking changes or things that become obsolete. So it probably would be good for them when they are aware to just at least like, you know, post something on that wiki page that says this is now outdated, whatever, because it may not always be possible, or at least notify the community manager, whoever that happens to be, right? Which sounds like Doug just volunteered for that. But anyway.
Maybe the core contributors aren't keeping track of where all the wiki pages are as well.
Right, I think there may be just pockets of awareness that aren't fully overlapping, right? So anyway.
Yeah, I just have a question more on like technical DevOps side, because I was using not OpenShift but like Kubernetes for a Swarm cluster, and all of these tools seem really great at hiding thousands of microservices and containers in front of one load balanced web interface, because that's what the Web 2 needs. But when we want to run a whole cluster of Swarm nodes, we want each one of those Swarm nodes to be able to communicate in a peer-to-peer network, which means they have to have an individual identity, you know, an address and a port, so they cannot just be copies to each other. So all of these great tools like Kubernetes automatic replication and scaling we couldn't use because they just make identical copies, and so we had a lot of replica sets with replications of one and then had 50 of those because it just didn't fit into the Kubernetes mindset to have peer-to-peer nodes with individual identities, you know. As Nick Johnson told me, you know, in Kubernetes, think cattle and not pets, right? You know, so I was wondering, is OpenShift better at that? Can you scale, you know, spin up 20 nodes and have them all be slightly different address, different port, but otherwise the same?
So these kind of problem is OpenShift aiming to solve and is basically solving. It's a bit more convoluted, so it's not easy just pressing plus, but there are solutions. There are so-called stateful sets. There are so-called more advanced stuff that you can do. It's not ideal, and you cannot move the manual work out of this. You know, what you cannot move, you can easily move images, but you cannot easily move configurations. So this is something that there is basically no solutions. If you change your configuration in dev environment, you must either write custom script to move it, or you just manually retype it. So this is not godsend solution, but it does help you to test and construct different topologies and then describe them and give them to somebody to easily replicate them, because it's just a JSON describing it. So I think there are values in it. And when you know what kind of deployment is optimal for you, you can easily push it to a production environment. I have a bit more faith in RedHat setup of Linux than I have in my own. So I kind of like to have the nice bottom on which the thing is running on. So this is not a godsend solution. There are challenges exactly like that one. What happens when you have 20,000 nodes with each a different configuration? Then you're basically fucked. And you have thousands of config maps. Similar with Apache Kafka. For each topic, you get a config map, and at the end of the day, it's like 5,000 files. Configuring your own topic. So there are challenges, but I think this really helps to build and iterate more easily. Maybe not for daily development, maybe with Minishift, yes. But when you decide to push it to production more seriously, then this really helps. Even if you have manual work to set 100 configurations, but there's always ways to automate it. If I can just end. So to finish things up, I opened up a Swarm OpenShift repository, which is currently empty, just initialized. This is the place that I will hopefully in the next days deploy some things, because it's possible, it's not impossible, it's just convoluted.
Are you here for the hackathon?
Unfortunately not, I'm here with my daughter, so I'll move out to home. But I would like to include online communication. And basically, thank you for your time. And I hope that I wasn't too out there, but this is something that cooked in me for a long time, and I just need to get it out.